Are you guys ready to have some serious fun? Good, because this topic's going to get nuts. I'm serious. So, anyway, we've learned from prior topics, guys, that 1,5-dicarbonyls have the ability to undergo intramolecular self-condensation and form 6-membered enones. Okay, remember we drew these before, okay? Now, what's different is that now we've also learned a reaction that makes 1,5-dicarbonyl compounds, and that's a Michael reaction, right? Well, when the 1,5-dicarbonyl is generated from a Michael reaction, that means that you had an enone and an enolate come together to make a 1,5-dicarbonyl. And when that molecule cyclizes, that's called a Robinson annulation. So essentially, this is an aldol times 3, okay? How does that? Well, because think about it. You had to use one aldol to make the original enone, right? Right, the alpha beta unsaturated, that's one aldol. Then use the second aldol, the enolate, to attack it via conjugate addition. When you did the conjugate addition, now you made the 1,5-dicarbonyl. But now what we're saying is that now that 1,5-dicarbonyl is going to cyclize on itself and make a new 6-membered enone. So that's the third aldol, and that's all enolate mediated. So I know, it's like too much fun, right? Not allowed to have this much fun in Orgo. So anyway, guys, here's an example of a Michael product, right? A Michael product, because I've got a 1,5-dicarbonyl. And again, I would be faced with the choice, where do I put the enolate? Do I put it in the blue or in the red position? Well, you're going to put it in the position that's going to give you the 6-membered ring. So if I use the red one to attack this carbonyl, do I get a 6-membered ring? I get 4. 1, 2, 3, 4. However, if I use the blue one, 1, 2, 3, 4, 5, yes, I get what I'm looking for, guys. So this is called the Robinson annulation. So what I'm going to do first is I'm going to help you guys draw the product, and then we'll do one from scratch, okay? So for this molecule is really easy to draw. Once you have everything numbered out, you can draw your 6-membered ring. And I'm going to continue to keep those positions the way that I had them, where I have 1, 2, 3, 4, 5, 6. Okay? Now I just have to figure out what am I missing on each of these atoms, okay? So 2 is going to be a ketone. 6 is going to be what? Well, 6 is going to be that alcohol, right? And it's also going to have a methyl. So that's the product. But we know that these like to dehydrate, right? So then, I guess I shouldn't have drawn it in the box. My bad. But the final product of this would be methyl here, double bond here, and that is your cyclic enone. And we've done this before, guys, but now specifically, this is called a Robinson annulation because it started off with a 1,5-dicarbonyl that was made through a Michael reaction, okay? So, similar to what we've already done, but just connected to conjugate addition. So what I want you guys to do for this product is notice that I'm starting off from, what is it called? From the Michael reaction. In this one, I'm start from Michael, right? Because what I have is an enone and what is going to be an enolate, okay? So I want you guys to react those together, get your Michael product, and then do the Robinson annulation for that. Try your hardest, and then I will come in and save the day eventually.